I think all of you will choose the GCE separate or the IGCSE or the GCE stream. So actually, I advise you that to work hard on these topics because like when you're taking the GC math, if you want to take one more subject in GCE, the best choice will always be the further pure mathematics. And 50% of it is just the mechanics. It's about the physics, okay? So that means if you can master this conversion, and then most likely 50% of this subject you're master in this 50% already. You need to just put 50% more effort, and then you can take one more elective. You can only take three subjects in GCE, and one subject is and plus Chinese. So if for your university admission, it's better for you to take four subjects. If you want to admit to, let's say, for Oxbridge or those universities in US. So this commission is not just for getting prize for this commission. It's also for your further pure mathematics. Okay. So I think George and June they are form 4. So are you going to take what subject are you going to take in next year? June?
Um, Physics, chemistry, and math.
Oh, sorry. Chemistry, physics, and math is it?
Yeah.
So will you consider to take one more subject?
I'll think about it.
Yeah. Okay. I'll see. I'll let you see a question paper. Okay. Uh, we'll cover all the topics in this course during this summer. But of course, you need to do those past paper and then to have a look. So we first of all let's go through the mathematics that you need for this combination. Right. I've written all the. Okay. So first of all, you need to know about these identities. Okay, just have a look. Let me know if you have any question. No lah. Then let's move on. Yeah. I think we should all have mastered the algebra. Otherwise, you will not be here. So next, go on. So the next one is the quadratic equation. Have you learned about this formula, or who haven't?
We didn't learn it from
Yeah,
school.
we didn't learn this.
Uh you have a look at the steps, okay, to see if you have any question. So the target there for you is just to make x be a subject of this formula, this equation, and then to make x be a subject of this equation, what you need to do is to computing square. Okay, I think you can look at it later on, but because it should not be that difficult. But you should memorize this formula in your heart, okay, in your heart. And also for your calculator that you are using in the uniform, they are also have the equation function inside your calculator. You can use it. But most of the question in Olympic are symbolic. Okay, that means there's no any numbers. You still need to know how to solve the quadratic equation using the symbols. Okay, negative b plus or minus square root b squared minus 4 is equal to a. That's it. Okay, do you have any question for this formula? I think the Form 4 have learned this equation already. Then let's move on. Now then let's have a look at this formula. Okay, this was the solution. So you can see there's a square root. So okay, we call this quantity to be the discriminant, right? Discriminant. So that is a b squared minus 4ac. Then we'll look at the discriminant. Okay, if the discriminant greater than 0, that's fine. Because what you have learned before, let's say square root 4 is equal to 2, you know about it, okay? But if it is square root negative 4, do you know what happens? That equal to. Now when you use your calculator, you know, when you press square root negative 4, you get math error. So that means there's no such solution. To be concise, you should say there's no real solution. I think you have learned about it before in mathematics. About uh, this one, is it? So we are looking at the discriminant. It's greater than 0, then that's fine. Then you get two, we say this distinct real roots. So just like this one, okay? So that means uh, negative 1 plus 1 over 2, that is 0. Or negative 1 minus 1 over 2, that is negative 1. Okay? They are two distinct real roots. If the discriminant is 0, okay, that means this thing will gone, will go away, and then what you get is negative b over 2a. Then you get two repeated real roots. And then if the discriminant is smaller than 0, okay, then there we will, you say there's no real roots, okay, because you can't calculate square root negative 4. But actually in mathematics, okay, they define I. This is an imaginary number to be square root negative 1. So square root negative 4 can be written as square root 4 times square root negative 1. So that is equal to 2i. We are not going to use the imaginary number in this commission, but it's good for you to know about it because I think you're going to learn it next year or next year. In this case, so let's say for negative 1 plus or minus I over 2, then you get two distinct complex roots. Or I can say two real roots, no, or you say no real roots, okay? Let me just talk a little bit more about the complex number. So let's say for a number that is written as a plus bi, I is square root negative 1. So this one we call it the complex number, okay? Complex number. And then for this one is called the real part because it's a real number. The number with the I, we call it the imaginary part. So that means the complex number include the real number and also the imaginary number. We can make use of this one to calculate a lot of things. It's quite useful in science and engineering, the complex number. So one of the formula is like the EI theta equal to the cosine theta plus I sine theta. This is called the earliest formula. We may use it in the last topic. Don't ask me how to prove it. You can know how to prove it later on. But first of all, do you know what is the number of E? George, I think you know about it.
Yeah, it's 2.17.
Yeah, this is a constant, just like the pi is an irrational number. So it has a value 2 point and so on. It's an it's a irrational number, just like the pi, and it's used very often in science and engineering. So this is one formula called the Earth formula. If you're taking the very pure math, and you learn about this formula. So take a screenshot. I'll send you a PowerPoint later on, but okay. Then let's move on. Hold on. Then the next thing is how we can now we first of all we deal with this quadratic equation, and the next thing is how we can deal with the function. So that means right here, okay, you take y equal to fx ax squared plus bx plus c. It's not equal to 0, okay, not equal to 0. And then you are going to find the maximum value or the minimum value of y. Because you know x is a variable, okay? So ax squared plus bx can vary with different values of x. So for different value of x, you get different value of y. Then we are still going to have a look at how we can find maximum and minimum. The skill is quite similar to how you solve the quadratic equation. So we are going to do the combinating square first. So after you're doing the combinating square, the formula will look like this one. Okay, look like this one. Now you may ask me why we need to do the combinating square. Now, originally, you can see there are two terms including the x. When the x change, these two terms also change. It's very difficult for you to look at the how y change with the x because these two terms changes. Okay, these two terms change. After you combine square, there's only one term containing the x. It's much more easier for you to determine how y changes with x. Okay, that is the rationale behind. And let's say for this equation, let's say if b over 2a is positive, okay, if this one is positive, then obviously you know that if x increases, okay, then this one will get larger and larger and larger. Okay, given that a is also positive, okay, then the y will be getting larger, larger and larger. Okay. Then in this case, when will the y has no maximum value? Y has no maximum value because when x goes to infinity, then y will also go to infinity. Then in mathematically, okay, that means there's no maximum value. Okay, so this is a rationale behind why we are combining square. And then we are going to have a look. We consider two different cases. One is a is positive, one is a is negative. So let's say what if a is positive, okay? If a is positive. So this is positive. Whenever you do the square of a number, it is always non-negative. It's either 0 or positive. When you're doing the square, it can only be greater or equal to 0. So, and in this case, you can find the minimum value of y. Because when this square equal to 0, and then it will give you the minimum value. Do you understand why? Okay, let me using the pool. Right, 我住喺度. So this is a constant. It does not change with the x. So this is a positive value. Okay, this is a positive value, non-negative value. So then the minimum will be when this value becomes 0. Okay, is it? I think all of you should get it. Then let's move on. But you don't have a maximum value because this one can go to infinity. So infinity plus some constant still give you infinity. So there's no maximum value. It only can has a minimum value. Then the minimum value will be 4ac minus b squared over 4a when the square equals 0. When the square equals 0, that means x equal to negative BO2A. That's it. Okay. And similarly, okay, I think you are able to analyze this question. If A is negative, then the only to get the minimum value of you can't have a maximum value of you can't have a minimum value of y because this is negative. If A is negative, this one can go to infinity. Then we multiply these two together, you will get negative infinity. So that means y when x goes to infinity, positive infinity, then y will go to negative infinity. Then there will be no minimum value for y. But there can be a maximum value for y. Similar to a greater than 0 lah. If this value equals 0, then you get a maximum value. Because this term will always be less than or equal to 0. So similar, okay. You get the maximum and you can get the maximum value of y and also when the y equal to maximum or minimum. Now you need to memorize these two, or what I suggest you to do, just like for those questions, if there are numbers, not the symbols, okay? What you can do is just memorize this term. Just give you one example, okay? One numerical example. So let's say y equal to x squared plus 2x plus 4, okay? So if what you can see from this equation, so a is equal to 1, that is greater than 0. A is a coefficient of the x squared. So a is equal to 1 greater than 0. So that means there y can only has a minimum value. It doesn't have a maximum value. It will go to infinity. And then if you remember this one, negative b over 2a, okay, b is a coefficient of the x, there's 2, a to 1, so you get x equal to negative 1. So when x equal to negative 1, y has a minimum value. And then the value of y will be equal to, what you need to do is just to substitute the value of x into the equation. Okay, then you get 3. Okay, then this is a minimum value of y. Okay, so that's why I just asked you to memorize this one. And then you can find the value of y without using that complicated formula. Another thing you can do for this one, actually you can communicate the square for this equation very it's very simple for you to communicate the square. And then this is obviously, this one is the minimum value of the equation of the function. Okay, so let's move on. The next thing we are going to do is to plot the graph for this function. I'm not teaching you to how to do the transitional reflection of the graph, but we are just looking at this one. Now you can use a decimal to plot the graph to show you some of the shape by itself. So let me give you some example. Yeah. Let me just plot the graph or the question we have done just before. So this is a graph of the x squared plus 2x plus 4. So you can see that this graph only has a minimum value at 3, at y equal 3, do you see? And when x equal negative 1. Yeah. And you also need to have a look at the shape of this graph. So this is this one we call it the concave upwards. So you can see its mouth face here. It just look like a joker. Okay? The Marvel movie, right? The Joker. Okay? The mouth is too large. Okay, and how about if I turn the value of a to from 1 to negative 1? Then the graph will become concave downwards. The shape will be different, okay? The shape will be different. So the value of a will will affect whether the graph is concave upwards or concave downwards. Then let's go back to the PowerPoint. So the shape of it, okay, and then the y-intercept, x-intercept. I think you know how to do it. I think you know how to find it. For the x-intercept, that means when x is 0, then x-intercept is when y is 0, then you're going to find the value of x. That means you are going to solve the equation. When y equals 0, when y equals 0. And for looking at the discriminant, you see how many x-intercept there. So if discriminant greater than 0, you get two distinct variables. That means there are two x-intercepts. When discriminant is 0, and then you get one x-intercept. And when discriminant is smaller than 0, you get 0. Because you have no real solutions. You get 0 intercepts. Y-intercept is when x equals 0, then you get the value of y. You can solve it easily. And the shape of the graph I talked about it already. So then let's have a look at the next one. Here. Okay, I think I have talked about this already, so let's move on. So this one I summarize different shape of the graph for you. So if there's no solution, then the graph of it will not touch the x-axis. Okay, if it is touching the x-axis, that means there is a solution. So this one is just a touching the x-axis. So this one crosses the x-axis twice. This one okay. Then let's move on. So while I'm going to teach you how to draw the graph, most likely in physics you are not going to draw the graph, because I'm going to teach you how to solve the quadratic inequality. So let's give you one example. Okay, let's have a look. Let's go back to the graph in the decimal. Do you see? Is it good? You're seeing the decimal? Yeah. So I change the negative to go back to the positive. Okay. So this is a function. Okay. This is a function. It's not an inequality. So let's say if we are going to want to solve the inequality. So let's say if we want to solve y greater than 0. Okay. Okay. Let me. Okay. Maybe you give me your answer. So what does it mean by the solution of this inequality? So that means you are going to find the range of the x values such that this inequality satisfies. So beyond, may you try? So what will be the value of x such that the y is always greater than 0?
1.
1?
Yeah.
How about 2?
Yeah, 2 also.
So what will be the range of x? Actually, this is a trick question for you. Can you see that all values of x, for all values of x, y is always greater than 0? That means actually the range of x will be all real numbers. Okay, all numbers of x can give this y greater than 0. That is all real numbers. Okay. So let's say if we are going to solve that, okay, y is greater or equal to 1. Okay, it's still fine. What you can see is all the y values always greater or equal to than 1. Then the range of x is still all real number. Okay, all real numbers of x. The solution will be all real numbers. Okay, if y is greater than 1, then you know it seems that all real number of x is a solution, but not, because when x equal to 1, I should write it like this. Okay, y greater or equal to 3. This this is y equal to 3. So when x equal to 1, then y equal to 3. So that means the range of x will be x is not equal to 1. Then all values of x that is not equal to 1, uh, then this inequality is still satisfied. Okay, so let's do something else. So let's say let me find some perfect point. Okay, the perfect point I think this one. Okay, 12. Okay, give a bit the challenge. Okay, so what will be the solution of this inequality if y is greater than 12? Is it how your name pronounced? A bit.
Yeah, yeah.
Yeah.
X can't be equal to 1.
Sorry, x can't be equal to 1.
Yeah.
How about 2? How about 3? And how
It
about,
can't be 2 either. It can't be 2 either, I think.
you need to give a range. You not just set
Oh,
up. You
so
not
it can't be 1 to 2.
1 to 2. How about
Yeah.
0?
0?
Mhm.
0 to 2, sorry.
How about negative 1?
Negative 1 on. So negative 2 to 2.
Negative 2? Are you sure?
Yeah.
Look, Ralph, how this straight line, how this horizontal line intersect with this graph.
So negative 2 to 1.
No, it's negative 4 to 2.
Negative 4 to 2.
Yeah, negative 4 to 2. So it can't be the value between negative 4 to 2. So actually we are going to write it not like that. We are writing like x is greater than 2 or x is smaller than negative 4. Okay. Let me give the chance to June. So how about if y is smaller than 12? What will be the answer? What will be the solution of the inequality?
Just swap the inequality sign.
Yeah. If y is uh you can't write it like that. If you write it like x smaller than 2 or x is greater than negative 4, I think this is what you mean. Is it? Then it will becomes all real numbers. Have you learned about how to draw the number line in uniform? So let's say this is 2. X is less than 2, then you draw it like this, is it? X is greater than negative 4, you draw it like this. Have you learned about it? I
Yeah.
think,
Yeah.
yeah. Then what will be the solution of this one? How to simplify this one? You get all real numbers. Do you know what I mean? You can see if negative 6 is still satisfied. Yeah, negative 6 is less than 2 is satisfied. Your solution also include the negative 6. What you should write is like that, okay, like this, okay? X is less than 2 and greater than negative 4. Just write them together, okay? And luckily, if you get a new calculator, I made the right one, okay? I think the form fit doesn't have one. I think June and George have one already. That's the 991 EX. Then you can use a function in 911, so 991. So you can use there's a function inside your calculator that to solve the quadratic inequality. But we are not going to see how we can solve it by looking at the graph. We are going to see how we can solve it in general without drawing the graph. But actually, it's better for you to draw the graph first. So let's go back to the PowerPoint. So if discriminant is greater than 0, first of all, you need to know how to draw the graph first. You need to determine whether the discriminant is greater than 0, equal to 0, or less than 0, and also whether the A is positive or negative. Unluckily, okay, you can't use the calculator that you are using in IGCSE in the commission. You can only use a uniform calculator in the commission. So let's say I'm going to solve this inequality, okay, or this one. Then after you draw the graph, and then you can highlight the part of the graph such that the inequality is satisfied. So let's say for this is a y, okay, this is a way of y. You see, what I highlighted red is the is a range of x such that this inequality is satisfied. So this part and this part y is greater than 0. This part and this part y is greater than 0, except this one. If the graph is just above the x-axis, all x value will make these inequalities satisfied. Okay. But if I change the question a little bit, okay, I just make it to be greater or equal to 0, okay, then you should also include the point of the x-intercept, okay. So you see that for this one it will become all real numbers, okay. This one is also all real numbers. I hope you understand because I'll give you exercise later on. Then let's have a look at how we can make use of the quadratic function to solve a physics question. So let me erase the solution. Okay, okay, shit. So let's say okay, let's say you can't see the solution. Okay, just close your eye for a few seconds. Okay, where's he? I can't clear. I can't clear the line written on the PowerPoint. Okay, then just leave it. Okay, just leave it. I know what happens. Okay, I know what happens. So this is a question from another physics Olympic commission. I think most likely they will not hold this commission this year. So you can have a look at the question first. So in the sea, there's ship A that's 25 meters, okay, and moving at 5. Okay, it's all shown in the diagram already. So you're going to find the minimum distance between these two ships. You know when they are moving, when they move, and then the distance between them will change. So there will be some time the distance between them will be minimum, because maybe after a very really long time, they're moving much further away from each other. Then the distance between them will increase later on. So, and then you're going to find the distance. So the trick to do this question is mathematically. Okay, you can make use of the quadratic function to solve it. Because the distance between them, you can use the Pythagoras theorem. Is it? A simple, Pythagoras theorem. But you are just not just finding the distance initially, the initial distance between them. Okay, it's useless. Okay, it's the initial distance between them, and then we are going to find the distance when as a variable of time t. Okay, that means it is a distance in general. It is as a function of t. This distance function of t. I use the d squared instead of d because I don't want to see the square root on the right hand side. So then you can write down d to be 120 minus 12t total square plus 25 minus 5t total square. I think you know why it's like that, is it? because after time t, the ship moves for the distance, that is 12 times t. You know speed times time, you get 12 times t. So it's 120 minus 12t. And then this one is 25 minus 5t, because the speed is 5. You may ask, okay, how about if it's a negative value? It doesn't matter at all. So let's say for time is 10, you know the distance traveled by the ship A will be 50. So you 25 minus 50, you get negative 25. It doesn't matter because you need to do the square root. You need to do the square. You still will get a positive value. Okay, then after you expand the brackets of these two terms, you get a quadratic function. Then you have learned how to, I think there's a t here. You have learned how to solve the quadratic, find the minimum value or the maximum value of the quadratic function. By using when x equals negative b over 2a. Okay, you can calculate the x first. That means the time t. When t equals negative b over 2a, then you can substitute the time t in this one. And don't forget to take the square root, okay? Don't forget to take the square root, okay? 532 is not your final answer. You're finding distance. You take the square root of this value and then get 23.1. Okay? I think all of you should be able to do this question right now. But actually, we are not going to use a quadratic function to solve this question. We are going to use a relative motion later on. So that means we are consider one ship is stationary. Another ship will move relative to another ship. In that case, if there's only one ship is moving, it's much more easier for you to determine whether the minimum distance between these two. The motion of the ship will just look like, let's say this one is stationary. So we consider the ship A moves relative to ship B, and then the motion will be most likely like this one. It's moving along a straight line. Okay, this is stationary. Just remember, this is stationary. For the minimum distance between these two will be just the perpendicular distance of this straight line to the ship B. Okay, it's much more easier to understand in the relative using the relative motion. But mathematical behind may be a bit complicated. So this is the first part of the essential math. It's not the end of the lesson, okay? Because I need to still rush for the mathematics that you need for the combination. So then let's move on to the next topic. Okay? This part is a quadratic function. You're also going to learn it in the RGCSE, the Form 4, I think. If you get the textbook, I think you already get the textbook. I think you should have a look at the textbook by yourself first. So then let's move on to the next one. The next part is much more interesting. Okay. No, not this one. Sorry. So this is about the geometric and arithmetic series. I think you encountered some of this series before. So let's say for even in primary school, you know about the sum of this series. Is it? What is the value of this series? You can type it in the Zoom chat. Zoom chat. I think you all know the value of this sum. Do you? Won't you get it wrong? How about the others? You don't know how to find the sum of this one? Yeah, Josh, you get it correct. It's 5050. Then we are going to learn how to find these two series, the sum of these two, find these two series in general. So first of all, let's deal with the geometric series, okay? So these two are the examples of the geometric series. The next term uh, uh, the next term is just multiplying by some values, the same value from the previous term. Okay, you can see 1/2, 1/4, 1/8. They're all multiplied by the 1/2, or you just say divide by 2. So 1 plus 2 plus 4 plus 8 plus dot 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 2 plus 5, 1, 2. So this is the uh, uh, also a geometric series. No formula sheet is given in the commission. Uh, those equations is quite easy already. Okay, so you should all memorize it in heart, or you can derive it later in the commission. So to find this series, okay, so let me give you the trick for this to find these two the sum of these two. So 1 plus 1/2 plus 1/8. So you can do it like this, okay? You just draw a rectangle with the side 1 and 2. How you can find 1? Okay, 1 is the area of this half, is it? And then 1/2 is the area of this another half. So and then 1/4 is area of the remaining half, and then you add this all together, okay? Go to infinity. So that means you are carry every small pieces of these uh, rectangles. Then that is the final sum of this. The sum is actually the area of this rectangle. That's you 2. Okay, that's the trick how to do this sum. But if you're talking about 1 plus 1/3 plus 1/9 plus 1/27, okay, you can't use this trick to find a sum. Another one is 1 plus 2 plus 4 plus 8 and up to 512. So it's easier for you to do this trick by using the binary number. You know the binary number, is it? So 1, 2, 4, 8, they're all the 2 to some power. So if you look at it, okay, if you look at it here, so it's the sum of this one is the by number. First of all, you calculate how many numbers here, okay? 1 is 2 to the power 0. 512 is a 2 to the power 9. So that means there are 10 numbers here. So all of them are 2 to some power. Then the sum of it using the by number become 1, okay, with the base 2. So to do this trick, you just add another 1 in base 2, and you get 1 with 10 zeros. 1 with 10 zeros. 1 with 10 zeros. So that is 2 to power 10. You know the value is 1024. Then of course you need to minus 1 here. Then you get 1023. So this is one of the tricks to do this sum. But we are not going to learn just the trick. We are going to learn how to do the sum in general. So there are two different types of geometric series. One is the finite terms with the finite terms. Another one is with the infinite terms. So if it's with the finite terms, if it is for the infinite terms, then am I showing the I'm showing the thing. If it's an infinite terms, the R has some criteria. The R can only be smaller than 1 or greater than f1. I didn't teach you how to use the absolute value yet. I think it's still fine. So let's go on to. But why we can't do the infinite terms with R greater than 1? So I'll give you one example. So let's say if 1 plus 2 plus 4 plus 8 plus and then 512 plus 1024 and then so on. So the last term will become will tend to infinity. So that means the sum of this series is actually also infinity. Then there's no no any application for this one. Then let's move on. Then this one, let's say how we can do the trick. Actually, can I delete it? No, I can't delete the drawing I've written on it. So, oh, actually I can't delete. Is it? Okay, very good. So let me draw it on here. So first of all, this is a finite sum, sum of the finite terms. So I'll call it as n. Why I use a n here? Because you count the number, there are only n terms. This is r. AR is a to the power 1, 2, 3 to n minus 1. So here it has n minus 1 terms. Plus the first term, you get n terms in total. And then what I'm going to do next is I multiple this equation on both sides with the number r. So if a multiplied by r, what you get is ar. Ar multiplied by r, what you get is ar squared. And ar squared multiplied by r is ar cubed, and so on. The term just before ar to the power n minus 1 is ar to the power n minus 2. If it is multiplied by r, you get ar to the power n minus 1. This one multiplied by r, you get ar to the power n. So you can see that there are many common terms in this two equations, is it? These are all the common terms. And these terms, you don't know how many, there are n minus 1 terms. So you want to simplify it, what you can do? You just to do a subtraction, is it? So I do the subtraction for the second equation, subtract the second equation to the first one. So all the common terms will be deleted, and then what left is ar to the power n minus a. Okay. Then you try to simplify, factorize on both sides. Okay. Then finally you can find the Sn in terms of a, r, and n. Okay. That's how you can solve this finite. So if you just go back to this example, okay, 1 plus 2 plus 4 plus 8 go to 5, 1, 2. So let's say how we can use this formula to find uh, the sum. So 1 plus 2, the last one is 5, 1, 2. This is 9 to the power 9, 2 to the power 9. This is 2 to the power 0. In total, there are 10 terms. A is the first term. If you look at the formula. R is a ratio between the terms, so that means that R is equal to 2. Okay, so we substitute in this formula. The sum of 10 terms. A is 1, R is 2 to power n is minus 1. R is 2 minus 1. So this is 1, this is 1. So obviously you get this is 1024 minus 1. That's 1023. Okay, that's how you use this formula to solve the equation. To solve the sum. But we are not just going to solve the sum of finite terms. Sometimes we are also going to solve the terms with infinite terms, just like this one. Let me delete it first. Okay. I can't delete it. Okay. Then leave it. Okay. Oh, sorry. Then how can we find this one? Now, this is an infinite sum of infinite terms. Just use a symbol as infinity. Actually, you're going to use the same trick. You multiply by r, you get the ar plus ar squared plus ar cubed plus go to infinity. goes to infinite terms. And then you can do a subtraction s infinity minus r s infinity. Only one term's left. It's just an a, is it? Then you get s infinity equal to a over 1 minus r. Then you can solve this one very easily. Then just go back to the example we have taught in the first 2 pages. This one, go to infinity. So the a is the first term, it's 1. R is the ratio, that's 1/2. So give you 2. That's how you find the sum. Okay. Of course, you can also derive this equation from what you have learned it in the what we have derived it from the last page. Is this one. Now remember that the R should be greater than -1 and smaller than 1. So if n tends to infinity, so let's say when R is 0.9, I hope you have tried before or you know about the result. If it is 0.9 go to infinity, to the power infinity, it gives you 0. Is it? You know when you multiply by 0.9 to a number, this number will get smaller. And then multiply another 0.9, you're getting smaller and smaller and smaller. So if you multiply by 0.9 to power infinity, then you finally get 0. So then that means you can write this equation like a -1 over r minus 1. Then you simplify it, you get a over 1 minus r. Okay? I hope the geometric series is quite simple. Is it? Then let's go to have a look at one. Why did we take a to be 1? A is the first term of the series. A is the first term. The first term is 1. Okay. Just close your eye for 1 second, okay? Done. So I would like you to do this question, okay? Let's say a ball is released from rest at the height of 1 meter. I'll give you 5 minutes. After you have done it, you just type your answer in the chat, okay? At the height 1 meter. And during each collision, 1/2 of the kinetic energy is lost at heat and sound. Find the total distance traveled until it stops. May I change the question a little bit, okay? May I change the question a little bit? So, during each collision, 1/4 of the KE is lost. Okay. So it hit the ground and it will be bound, and that means it can go to up to the height 3 over 4 meter. And then it go up 3 over 4 meter and go down 3 over 4 meter and then hit the ground again and then rebound and then go down and hit the ground again. Each time the distance will be the height will be just 3/4 of the first one, okay, or of the previous one. So that means okay, 1 meter and then a 3/4 and then it will become 3/4 square. So I would like you to find the total distance it travels until it stops. Do you all understand the question? If you don't, please ask me in the chat or you just turn on your microphone. So I give you a few minutes to do it. So the formula, okay, I think You may not remember the formula right now, so the infinite sum is just A over 1 over R. A is the first term, R is the ratio. You're going to find a total distance traveled. So 5 minutes time. Oh, sorry, I muted myself. The answer is not 2. So may you show me your step in WhatsApp? So let me have a look at why you get it wrong. 4 over 3? No. 7? Let me check. You need to, this is a physics related question. It's not just mathematics. You need to think about how the object, what is the motion of the object. Yeah, June get it correct. If you don't get it correct, may you send yeah, George get it correct also. Okay, the form 4 get it done first. So how about the others? Yeah, just really advice. Just you work hard on this commission, then you will get advantage uh in your GC math, GCE further pure math, and also the GC physics. So that means this commission can actually help you fee electives. Because we are going to use the mathematics very intensively in this commission, especially for the trigonometry. 4 is not correct. So then, okay, so are you still working on it? Or let me show you the answer. Let me show you the answer. So first of all, I made a trick. Actually, I didn't show you how it moves in details because I want you to think about it by yourself. So first of all, you go down for 1 meter, yeah, and go up, and then there's 304, then go down 304, and then go up 304 square, is it? And then go down 304 square, and so on. So you add these two all together. It's 1 plus 304 plus 304 plus 304 square plus 304 square, and so on. I hope you can see the pattern behind. So it's just 1 plus 2 times 304 plus 2 times 304 square, and so on. Okay, I think you can see the pattern behind, is it? If you simplify the pattern, you can either simplify it like this, and go to infinity. Then here is a geometric series. Here is a geometric series. Then obviously you can apply the formula. That is the first term over 1 minus ratio. The first term is 304. The ratio is 304. Okay. Then here for this one, you get the value is just 3. 3. So that means the answer is just 1 plus 2 times 3. Then the answer is 7 meter. Okay. You can also simplify the fashion like this series like this. You plus 1 and then minus 1. Then it become 2 times 1 plus 304 plus 304 whole square, and so on. Then minus 1. Then for this series, you get the values AA is 1, and then 1 minus 304, then minus 1. This one you get 4. 2 times 4 minus 1, you still get 7, of course. Then the answer is 7. Okay, you can take the screenshot. Okay, then let's move on to the last part. Almost the last part for this lesson. The first lesson will be shorter. Then later on. Okay. So this is an arithmetic series. Okay. To add it to 100, okay, you get 5050. But you may search it online. Okay. I think you may be interesting why it is like that. Okay. You can type in Google. Okay. You can Google it 1 plus 2 plus 3, go to infinity. Then yield to negative. It gives you the answer is negative 1 over 12. So this is the result using in string theory. One very difficult field in physics. It's just like right now the smallest particle, the smallest particle in an atom is just the electron, neutron, and proton. But actually, you can still split it. You can get quarks, and later on, if you split it a little bit more, the physicists propose that all the materials can be made of string. Then they need to use this result in string theory. But don't you can search online, you can know the reason behind. And then we are going to find this series, or find the sum of this series. First of all, we're not going to add up to the infinity. Because if add to infinity, you get most likely you get negative infinity or infinity. So D is a difference between the two terms. So that means you add or minus d for each term, each one, and so on. So totally here, right here, there are n terms. We're going to find the sum of these n terms. Then the trick is like that. So let me delete it, okay? It's so complicated here. Okay, so let me show you how we can find this sum. So let this to be s. The trick is quite similar to the trick we use to find the sum in geometric series, but a little bit different. It's just like we reversing the order of the terms. So the first we reversing, that means it's a plus n minus 1 times d, and then a plus n minus 2 times d, and so on. The last one and add to a. Okay, I think you know what this means by reversing order. Then you add these two sum together, these two s. Okay, you add these two together, what you get is 2a plus n minus 1 times d, is it? You add these two terms together, you still get 2a plus n minus 1 times d. For the last term, you still get 2a plus n minus 1 times d. All these terms are the same, but you add up n times. So that means the sum will be n times, 2s will be n times 2a plus n minus 1 times d. And then you're going to divide by 2, so n over 2, and then 2a plus n minus 1 times d. Okay? Okay, that is your final answer. But most likely I'm not going to write the sum using this form because it's very difficult for you to memorize. So I will just make a trick here. A is the first term. This is the last term. So you're going to do a sum of the first term and the last term, and then multiply by the number of terms, and then divide by 2. Then you get the sum of this arithmetic series. Okay? This is a trick how we can do the sum. And similarly, for the first arithmetic series we have encountered, this one. You know the trick. So you know 1 plus 100 is 101. 2 plus 99 is 101. And then if you're pairing like that, in total there are 50 terms. Is it? It's just like 101 times 50. That's why you get 5050. And they're similar trick. So that's it for the arithmetic series and geometric series. So let me let you know what we are going to learn in next math lesson. Just a second. The next one will be a bit more complicated噶啦. Yeah. The next one is the vector, I think. Yeah, the vector. You know a little bit about vector before. But we are going to learn how to do the addition, subtraction, and multiplication of vectors. I'm going to do some examples. Do some yeah. Yeah. The detail give you more details on how we operate with the vector. So right now I want to discuss the time for the lesson during the summer. So if you have your timetable or if you have your timetable or your schedule, may you take it out first. May you take it out first. Like I can do it on the most likely for the weekday later on. I can only do it at night or for the lesson in weekend is fine. But during the weekdays we need to do it at night.